Hello everyone, welcome back on course of higher surveying, and today we are in the new module called photogrammetry, which is module 6. So far we have covered 5 modules. In the last module we talked about a technology called GPS, and basically we discussed about the additional information that is somehow not covered in the other courses on surveying. But today we are going to start a completely new technology, photogrammetry, and this module has 8 lectures. This is the largest module on this course, and it has 8 lectures. First is the introduction, second one will be vertical photogrammetry, stereo photogrammetry, then we have analytical photogrammetry 1 and 2. Later we will cover photogrammetric products which are developed as a process of photogrammetry. Then we have 2 lectures on digital photogrammetry, which are very special lecture from the perspective of digital photogrammetry. Rather, they are the additional lectures in the view of digital photogrammetry, and one is image matching and other is close range photogrammetry. Yes, close range photogrammetry was performed earlier also, but in the digital photogrammetry, with the perspective of digital photogrammetry, close range becomes more relevant today. So, let us start with the introduction. So, these are the books I will recommend you. Okay, let us see. In the first 3 books are easily available in our country, rather they are available with low price edition also. However, remaining books which are listed here, in order to refer these books, you should go to some library, maybe public library or institute library, and I will say that you should refer these books there only, because little expensive they are. Okay. So, this is the first time I am going to give you some contents in the lecture. So, for this lecture this is the contents, and the reason for giving the contents are, this lecture is particularly scattered and having a lot of information, and because of that reason we have to give some kind of categorization, that how we are going to cover these information step by step, and finally in the coming lectures we will be keep on connecting these information as and when we need them. So, let us start. The first thing is that we will talk about the visible range or optical range, then we talk about the definition of the photogrammetry, then what is the photograph and what is image, then we talk about the development of the photogrammetry, then what are the cameras with different types of cameras, what are the platforms those carry the camera in order to acquire the image, and then we have photographs, type of the photographs. Then we will cover the basic terminology of the camera like field of view, lens equation, aperture, shutter speed and other things. Finally, in the context of digital photogrammetry, we will talk about the cropped sensor, and then we will talk what is the photogrammetrist view on the camera and how a photographer look at the camera. We will look into these aspects today. So, let us start here. So, first of all, if you look into the electromagnetic spectrum, that is the spectrum of our light, you will find that this is the wavelength range here shown from right to left, which is in general contrary to our understanding. Generally we go from left to right, but there is an issue here. If we draw the frequency of these wavelength, then I will be going from left to right, and that is the only reason in the books. Most of the books show the frequency on x-axis, because wavelength is increasing from right to left if frequency increases from left to right. And you know the famous relationship of light, or into if speed of the light is nothing but lambda into mu, which is lambda is wavelength and mu is frequency of any wave or electromagnetic wave. Now, in this electromagnetic wave, if we look at this figure called 400 nanometer and 700 nanometer, you might have come across these. You might have come across some term called VIBGYOR, right? Violet to red colors. These are the 7 colors. So, this is my violet and this is my red. Or rather I can say that in the electromagnetic spectrum, the wavelength of the violet color is 400 nanometer and red color is 700 nanometer, and they are basically close to that. Exact value of red is 720 nanometer. The exact wavelength of violet color is 380 nanometer exact. But however, in general, this is a good idea to consider in the range 400 to 700 nanometer. And this is called the optical range or the visible range. Why? Because our eyes are sensitive to these wavelength range only. That means whatever color I am seeing here around me of this room, maybe I can say this is the black color, this is the red and white color combination on the shirt, or we can say this is the white color on this mobile phone. So all these visible colors are in this range 400 to 700, and that's the reason we say it optical, or the word optics has derived from here only. So remember, if anything related to visible light, it is called optics. Optical camera, we have a term. That means the camera that works in the range 400 to 700 nanometer wavelength. That's called optical camera. Well, I hope that's clear now. Then let us start with the basic definition of photogrammetry. What is a photogrammetry? If I explain you in layman's language, photo means photograph that you acquire, and then you have metry as a suffix to this term photo, the photogrammetry. So the photograph and photogrammetry, the difference is very simple. Whenever you use a word metry with something, that means I want to do some kind of three-dimensional measurement using photographs. So it becomes photogrammetry. Similarly, we have terms like lidar grammetry, we have terms radar grammetry, we have terms bathymetry, we have terms gravimetry, right? So these terms are using the same suffix metry, that means 3D measurement by some means. It could be photograph, it could be lidar, it could be radar, and so on. So the standard definition of photogrammetry, which I have taken from some source, that is, photogrammetry is the art, science and technology of obtaining geometric information on the three-dimensional shape and orientation of objects from photographs and other imaging sensors. Okay, so that is the standard definition. Okay, and again we are showing here the range of visible, which is 400 to 700 nanometer, or optical range, visible range. After that, we have near infrared in the wavelength range. Then before the visible, we have ultraviolet. Because it is before the violet, we call it ultraviolet, right? So now we are talking about the visible range in the photogrammetry. Okay, so what do you mean by photograph and image? We need to first consider these basic terms. You might have come across many a times. You might be using these terms very intuitively. Someone says that this person has a negative image in the brain of others or in the mind of others. Does it mean the same image? Okay, so let us talk about the technical definition of photograph and image. So let us say this is my camera body shown here in the screen. Now light enters into the camera and light goes to the some film here. It could be film or sensor. Let me tell you what is a film. Film is kind of polyester or acetate based medium where once it is sensitized or once it is exposed to the light, it cannot be used further for second time. It is completely different from the digital sensor or what we call today digital camera. So this is a film is not a digital sensor, remember, right? Secondly, we have sensor these days, what we call the digital sensors. So both are different things. So now in the perspective of two things, film and sensor, we are defining the terms photograph and image. So let us see again. So then this light will sensitize the film. So right now I am assuming that there is a one film here, there is no sensor. So let us assume that there is a film only. Okay, once the film is sensitized, then we develop the negatives by some process, chemical process is there in the laboratory like this, and then from these negatives we develop the positives, what we call photograph on paper, right? Or these photopositives are called the photograph. So the idea here is, if you follow this process where light enters and sensitizes the film, and then from the film we develop negative and then positive and so called photograph, then this process or the process that gives me the output like this, it is called photograph. The output is called photograph. Let us consider another process where instead of film I have a digital sensor, right. So, let us see there is a digital sensor, light has come here, okay. Then there is a sensor, again I am putting both words film and sensor, okay. Then the light will interact with the sensor, and because of this interaction at certain point electricity will be generated, because we remember the semiconductor physics or semiconductors has the property, some of the semiconductors, that if light interacts with that, they will release some photons, and those photons will generate some current, and this current will be generating some voltage, and that voltage now we will measure and convert into some digital number like this, and my so called product, that is what we call image, will consist of some digital numbers. So, by this process where we have light interacting with sensor, generating some photons, photons are generating current, currents are generating the voltage, and voltage is converted to some digital number, the final product is called image, and that is the difference between photograph and image. Now, you can imagine we have something called photograph in image in optical region for the visual. However, for microwave region in the spectrum, we have a term called radar. So, we never have radar photos, we always have radar images. Why? Because there is no process like this in the radar. There is only this process available in radar, and that is why we say radar images. Similarly, we say LiDAR images, right. So, that is the idea about image and photograph. You should always use proper terms in any of the discipline. Moreover, as on date we are using digital sensors, and one of the digital sensors are mounted in most of the cameras, they are inbuilt now. So, they are basically using this lower process, not the upper process. So, that is why we should use the term image today if you are using a digital sensor or digital camera, right. Let us go ahead. Okay. Now, we are talking about the early stages of photogrammetry. So, Kepler has first conceptualized the idea of camera. That means there is a person here, and if there is a pinhole in the box, so one can acquire this image, right. So, now you see that person is looking inverted here, and that is the idea here, because a ray which is coming from this point, it is going this point, and the ray from this point is going to this point, and as a result there is an inverted image is formed on this screen, and what we call here is negative or negative plane or whatever, right. Now, there is another development in this year, the person called Nadar, he has first acquired the aerial photograph, well, using hot air balloon. That means in the hot air balloon a person was carrying a camera, and he first acquired the aerial photograph. We should say aerial photograph because the camera was in those days based on the film, not the digital sensors, right. Later on, around this year, some more experiments were done, and pigeons were mounted, or rather cameras were mounted on the pigeon, and pigeon used to fly with their natural capacity, and they used to bring the information, and the idea was to do spying, right. But still it was not a bad idea to acquire the photographic information from a height, and that was the concept of doing the aerial photography first came into picture. Okay. So, in the early development, the first photograph that was developed by some scientist called Joseph Nisphone, and it took almost 8 hours for him to develop. Well, this was the early stages of development. Then first practical photo was delivered by this year by this gentleman Jacques Maury, and then later on Dominique Francis used the term in this year, the photogrammetry. The first term where he says that photograph can be used for 3D measurement. That was his idea, conception. However, in reality, this term was started using by Dr. Albrecht from this year. Okay. Now, if we look into the history of photogrammetry, you will be surprised there are basically 4 stages. First stage we have already discussed, where Kepler and all they have contributed, and that stage started from the 6th of the century. However, the real development or the real the passion for photogrammetry started much later because of the resources and because of the development and research and so on. So, the main stages were 4, but we have already talked about first stage. The second stage was analog photogrammetry, where some kind of mechanical instruments were used to create the 3D from the photographs. Later on, we shifted to analytical photogrammetry, where we started with the scanning of the photograph, and those scanned photographs in the form of images now, they are supplied to the computer, and by using the analog computers, because computers started under development. So, using those computers and the scanned images, we started doing the development, and that is why we call them analytical photogrammetry, because analytical part has come evident. Nowadays, as time passes, from analytical we have started to generate digital computers, and with digital computers we started digital photogrammetry. So, these are the basic 4 stages in the photogrammetric development. Today, we are in the era, or we are in the phase of digital photogrammetry. Let us look into what are these basically analog photogrammetry. Very briefly, we will talk about these. So, concept of creating 3D model was there already. So, by making the projection of 2 relatively oriented images using intersection of set of homologous bundle of rays. We will talk about in detail in this module, but for time being, the 3D model was started to develop. What's the idea here? If I have 2 images like this, if I place them parallelly, orient them appropriately, and if I take bundle of rays, means one ray from here, one ray from here, and they are targeting at some point on the ground. So, using these 2 photographs or 2 rays, I can find out the coordinate or 3D coordinate of this point on ground. So, that was the idea of development of the 3D models, and that started with the analog photogrammetry. So, these are the basic inventions. If you look at planograph, double projector, stereo comparator, stereoautograph, autocartograph, stereotopographene, and all these are the early development in the analog photogrammetry. However, today they are more or less obsolete, because later the analog photogrammetry was replaced by the analytical photogrammetry after the invention of computers. Further, the analog computers were superseded by the digital computers, and even the analytical photogrammetry was replaced by the digital photogrammetry. Okay. So, in case of analog photogrammetry also, this is the idea of vertical stereoscopy, what we call having 2 images simultaneously put together and try to find out the coordinate of a point in 3 dimension. So, there are 2-dimensional image. So, I am putting 2 images together and trying to find out the 3D coordinate, and we will see all this development, or we will see all these concepts very carefully in this module. Okay. In those days, they used to have mechanical machines like stereo plotters, and they used to use this one to create the 3D using acquired photos from the aerial photographs or maybe terrestrial one. Okay, then if they were not able to acquire the photo by stereo logic, which means let us say there was some place on the land surface which could not be acquired with the help of stereo photographs, they used to follow the convergent photogrammetry or convergent photography, where they used to put 2 cameras like this and 2 cameras not like this, rather on this view. They used to acquire the photo like this, and they used to use again stereo plotter to develop the 3D models. The idea was to have some overlap between the 2 images. That means, if there are 2 images, they are acquiring the same land, or rather they have some overlap more than 50%. So, with this overlap, they used to develop the 3D model for the only overlap area, not for the non-overlap area. right? So, let us try to get into this thing. Okay, the third phase was analytical photogrammetry. So, it was based on the stereoscopic vision of digitized images, which means whatever images or photographs we used to create using negatives, that means we used to create positives, what we call photograph, using the negative films. From those photographs, now I started using the scanner, and we started using the scanning of those photographs. And those images which are generated by the scanners are used as a soft copy images in the computers. And then, so the analytical photogrammetry started. Right? If you look at the various developments, then we have lot of development like collinearity and coplanarity conditions, space resection, space intersection, interior and exterior orientation, relative and absolute orientation, we have bundle adjustment and self-calibrating bundle adjustment. So, these are the basic concepts that came with the analytical photogrammetry, and we will talk about all these in detail in this module. Okay. So, let us go one by one. Basically, we are trying to understand what is the meaning of these concepts. So, we will take only few which are very, very important to understand now, and anyhow we are going to deal in detail with these concepts in coming lectures. So, let us first look, let us say this is my terrain and there is a point, we call it the object point. Okay. Let us see, there is a image and positive. So, this is my negative image or film plane, or I call today sensor. Well, this is my positive plane here. That means positive that I developed up from the negative. So far in the place in those days only negative was there in the camera. So, this is my camera assembly where there is only negative is there. So, now let us see that this point has been imaged into the negative, and as a result we will say this is my exposure station through which light passes into the camera or light goes into the camera. Okay. And then it creates, this is my image of the point, we will talk about that. So, this is my image of the object point, we call this point as image and not this point as image. Remember, this is the impression of this object point into the negative film, right. From the negative film we develop the positive, and the positive wherever this point comes we call image of the object point, and there is a reason for that. Let us see what is the reason. Let us say there is another point on the same terrain like this, terrain is like this, and there is a point here called B point, and this is my A point. Okay. So, B point, if I try to make an image in this one, so that will be like this, it will some here pierce here and it will go through the exposure station, and now it will create some kind of impressions. Let us say here, this is my small b, this is my small a, or let us call a dash and b dash, and let us call this point as a, small a, and this point as small b. If you look at this thing very carefully, you will see that we have some kind of experience of looking at the terrain. The idea here is, suppose if I am standing here, right, somewhere here, then I will see the point B is on my left hand side and point A is on my right hand side. But if from the same point of view, if I look at the negative, I can see here that the position A dash and B dash are relatively inverted on the other side. That means, now from my position here, point A dash on the negative is on the left hand side, which is completely contrary to the position of point A in the field. Similarly, you can see that B is imaged at B dash, which is on the opposite side with respect to this axis here, right. However, if you look at the positive, they are on the same sides and I have the same experience. The way I am looking at the world, I will get the same experience in the positive, not in the negative. And as a result, we always use positive for referring the any point on the image. So, we use the positive image, not the negative image. So, negative image lies in the camera, that is generally we develop even our sensor, if you look at the sensor also acquires the same fashion. They first create the negative, and then their software, internal software, it again develops the back and shows the positive on the screen, right. So, you should understand it first. So, although you are looking at the same thing in the camera, what you are looking at the world, but that is developed by your mobile phone or maybe your camera. So, that has some internal software to do that. And same way human mechanism, the human vision is also like that. Our brain always create an inverted images. So, later on brain converted back into the non-inverted or straight images, or the original images the world looks like to us. Okay. So, their idea was here that if I look at point A now, so small a here and this exposure station, they are all in one line like this. They are falling in a straight line, one three-dimensional line, and this relationship is called the collinearity relation. That means object point, the image point and the exposure station, they are in one line, they are collinear, and that is why it is called the collinearity relationship. I hope it is very clear and very easy to understand. Now, let us look into the another one, the coplanarity. What is the coplanarity? Let us look into that. So, let us see, there is a point, object point again here, and there are two images. These are two images here, and both images are acquiring some scene or some kind of information on the ground surface, and let us say this object point is acquired in both of the images. So, like this. So, I have, let us say, these two camera, and these two images are acquiring the image of this point like this. So, I can call it point A. So, let me call this A left, maybe this is A right, fine. Now, if you see that if I orient carefully these two images such that point A, this my exposure station, this and this, they may come in one plane. So, these are my image points, and now I have drawn this plane, say. So, if I orient my two images very carefully such that this line here and this line here, this triangle, two triangles, they come in one plane, automatically this plane will contain the exposure station, let us say O left, O right and the object point. So, these 3 points O, L, O, R and object point A will be in one plane, and this relationship is called coplanarity. They will be in one plane, coplanar. So, it is called coplanarity relationship. Okay. Now, let us divert to the types of photogrammetry, or still we are on the development phases of the photogrammetry. So, now we are talking about digital photogrammetry after the analytical photogrammetry. In digital photogrammetry, only sensor has changed. That means earlier we used to have film based cameras, now we have digital computer and digital sensor, which is my digital camera. And generally we have two technologies here, one is charge coupled device CCD, and we have CMOS, which has complementary material oxide semiconductor. There are two technologies which are used to develop these sensors, digital sensors. In most of the cameras what we use today, CMOS is more popular because it is less expensive. Okay. In case of digital photogrammetry now, there are some distinct advantages because of the use of digital computer as well as digital sensor, and these advantages has brought many new development compared to the analytical photogrammetry. Okay. So, first of all we have fully automated processing of the data. It is possible now. Okay. And as a result, there are very important thing, for example, image and feature matching. Suppose there are two images and they are having some overlap, or they are having information about the same area on ground. So, we say that they are overlapping images. So, now I want to find out which point here is also there. That means which are the common points in two images. So, that is why we say image and feature matching. Then we have automatic type point generation. Let us try to remember right now, and we will talk about these in detail in coming lectures. Then we have important development like scale invariant feature transform, SIFT algorithm, and this is very, very important in the era of digital photogrammetry. Okay, so let us go ahead, and now after the discussion on the various phases or various development of the photogrammetry, and so different like early stages, then we have analog, then we have analytical, then we have digital photogrammetry. So let us talk about the cameras. So we have in general two type of cameras, as we already disclosed it to you few minutes back: film based cameras, and then we have digital cameras. Yes, in case of film based camera, we have a negative film which can be exposed only once to the light. So the moment it is placed in the camera, the cover of the camera is closed, and then the moment I take the photograph, light enters into the camera, it exposes the film, and that film cannot be used anymore. As a result, it has to be shifted and the new piece of film has to be replaced. Okay. So once we do, we again repeat the same process, and again we shift the exposed film to the roll. We roll it basically in the camera room itself, and then we keep on doing this process. And let us say if there are 36 pieces of the film connected together in one reel. So once the reel is over, camera indicates you reel is over. This means all the negatives are exposed. So then you will replace the whole reel by another reel, and then you keep on acquiring the photographs like that. That means you keep on exposing the films. It was slightly expensive affair. Why? Because I cannot reuse the used film. Okay, the film which is already exposed now has to be brought to the laboratory. There by some chemical process, we used to develop the films, and after development, we used to call them negatives. From those negatives, which are permanent in nature, now we used to develop the positives. So what do you mean by permanent in nature? When film is exposed in the camera, when it was standing in the camera or when it was housed in the camera, at that time I cannot use it. So we need to brought into the dark room where there is no light available. In the dark room, there is a standard chemical process through which film passes and it becomes a permanent in features. That means whatever features are there which are acquired in the film, they will become permanent on this. So now you can use it anywhere. It will not be removed. Okay, using those negative films, we used to develop the positives or photographs in the hard copy, and then we used to use those photographs. So this was the process of film based cameras. In case of digital camera, we don't do anything, rather we click it and then we immediately transfer our data to the laptop or computer. So that is a fundamental difference in the analog camera and digital camera. Well, the photographs here are given for the consumer grade cameras, although these categorization also true for aerial cameras and satellite cameras. Satellite cameras nowadays are completely digital in nature, but at times in around 1950 to 1975, they were in the analog mode also. That means we used to have film based cameras in satellite also, and famous Corona satellite program was having a panoramic camera. You can read the details on internet about that. Let's talk about the consumer grade camera, which means being a consumer, I am using some camera. It could be SLR camera, it could be point and shoot camera, it could be mobile camera, all are called consumer grade camera. Okay, so now we have again the consumer grade camera, film based as well as digital. Most of you and including me today, we are using digital cameras, but still there are some passionate photographers, they still use film based camera today because they have a passion to use those. Rather, they are habitual of using those, and they feel there are a lot of advantages with analog camera or film based camera. No problem. But nowadays, most of us have already shifted to digital cameras, and it is very easy because it is a less expensive. Why? Because unlike negatives, it does not have a permanent kind of stuff. That means once a negative is exposed, it cannot be used for taking another photograph. However, in case of digital camera, once you take the photograph, you keep on using the same sensor for acquiring another photograph, or rather photograph which is acquired by the sensor is transferred to some kind of memory or some kind of hard disk. and that's the reason it vanishes the information whatever it acquires, and it is again ready to acquire new information. And that is the advantage of the digital camera, and hence this technology has more or less replaced the film based technology. Okay. So now we have small format, medium format and large format, and these formats are also equally applicable to aerial cameras. Whereas I would like to say here that these definitions are more or less stable for the consumer grade camera, but in case of aerial cameras, this is changing very rapidly today. So that is why we are not specifying any limit for the or any criteria for the digital aerial cameras, right. So in 2009 or 10 there was some paper in journal Photogrammetric Engineering and Remote Sensing, PERS, where some definition was there. I do not know whether that definition is valid today or not, but they have specified some, what is a small camera, what is a small format camera, what is a medium format camera, and what is a large format camera. And if I can recall something like a large format camera has a pixel size of 250 megapixels, but it is about aerial camera, not the consumer grade camera. Here in case of consumer grade camera, we have something like 12 megapixels, 20 megapixels, maximum 50 megapixels, right. Okay, so let us go ahead. Then we have consumer grade camera. In the digital camera, we will see there are frame cameras. So what do you mean by frame camera? Okay, let me show you this camera. This is a mobile camera here. The moment I click it with this camera, what happens? In one click or in one moment, it acquires some information on the frame, what we call frame, and it exposes the whole frame of the sensor or maybe a negative film, and such kind of cameras are called frame camera, right. So we have digital frame camera, as well as earlier we used to have frame camera, which were film based cameras, no problem. So definition of frame camera is very fixed. Then we have stereo camera. What does it mean? Rather, they have two cameras into one box, and using stereography principle, they are acquiring the 3D model directly. Well, we will look into that, but we are just talking today about what are the digital cameras available in the consumer grade range. Now, let us talk about the platforms. Platform means something that carries the camera so that camera can acquire the image, or the camera can acquire the information on the ground surface. So the first is satellite. Okay. In case of satellite, satellites are projected by the rockets in their respective orbits. In orbiting around the earth, they also carry the camera, which is already mounted there, and the camera acquires the information. For example, now we have many sensors. Let us say Landsat. Even the Corona satellite was having some panoramic camera mounted on that there. Then we have QuickBird, then we have Iconos, and many such sensors are there. So even including, let us say, pen camera, we have panchromatic images, or we have spot sensors, or rather spot satellite we call, but it has some linear array sensor, and those were fitted or those were mounted into the satellite. So they were acquiring the satellite based information. Similarly, we have shuttles. They can also carry the camera in the space. Now, on terrestrial and airborne platforms, we can also mount the camera, right. And as a result, if we see that there is a tripod with a reamed bar, that means on this reamed bar here you can see camera is mounted, and this gentleman is trying to acquire some photograph or image or information. Similarly, now there is a tripod here shown in this figure in the image, where a camera is mounted over the tripod. You might have seen this kind of arrangement of tripod and camera assembly, or camera mounted on a tripod. Even we have the still cameras or the photographic camera, they also are mounted on the tripod to acquire the image information. What about the helicopters and aircrafts? Yes, we also do that. So, helicopter sometimes you will find out a term called rotary wing is used. For aircraft you will find out some term called fixed wing aerial vehicle. This term is used. So, I am writing this also. Yes, helicopter and as well as aircraft both can also carry the camera for aerial photography. So, now we have a kind of two terminology here. If I use the camera on platform which is used on the terrestrial way or on the ground surface, it is called terrestrial platform like this. Similarly, if I use or mount the camera in the aircraft or helicopter and they go up to certain height which is quite a high, then we call it aerial platforms. So, helicopter and aircraft are aerial platform, while tripod and let us say tripod with a reamed bar, they are terrestrial platforms, right. What if you carry yourself a camera and try to do the photography without tripod? Well, it will be called terrestrial photography or terrestrial photogrammetry, right, because you yourself is acquiring the photo on the surface of ground and you are carrying yourself and your height is more or less very limited on the surface of earth. Now, recently there is some more development happened in platforms. So, recently scientists and well as practitioners of the photogrammetry have introduced a new term called low altitude platforms. That means they are not terrestrial platforms like tripod, unlikely they are also not aerial platform like helicopter or aircraft, they are in between the two, right. So, first is the pole. Pole means we have almost 20 to 30 feet high pole, and the top of the pole we make some arrangement to hang a camera, and by some automatic arrangement on the ground we try to control it and camera acquires the images from that height of 30 feet or maybe 20 feet. So, that is the arrangement to call pole, and that comes into the low altitude platforms. Well, then second is kite. Kite, it has some special material, and like the regular kite that we we fly in the air for our entertainment, same way this kite is sent into the flow of air, and that thread which is connecting the human and the kite, it has some arrangement to suspend a camera in the air, and after certain height, when kite reaches to its peak height, at that time a suspension arrangement which is suspending the camera is using the camera to acquire the information. So, that is the arrangement of the kite. Similarly, we have a blimp. Blimp has helium gas filled into that, or even we have balloon. Blimp and balloon are the same kind of arrangement where they have helium gas which is quite a light gas, and then that balloon is again carrying the camera on its thread, and thread is connecting the human and the balloon. So, that is suspension arrangement is also there, and using that suspension arrangement camera is suspended in the air, and at certain height we try to acquire some information using that automatic triggering mechanism. So, that is the idea here. Further, we have drone which can go to around good heights 150 meter, 200 meter and so on. So, they are also classified in the low altitude platforms. Remember, the drone carries the camera. Drone is a platform and there is a camera. So, here you can see there is a DJI Inspire platform here and this is a camera here. Okay. Now, let us talk about the type of aerial photographs. As I told, the information in this lecture are quite scattered. So, we will go one by one, and you may feel that there is no connection between the two, but yes, these are the basic terms that we should understand before getting involved into the photogrammetry. Okay, so based on the position of the sensor, we have vertical photographs, tilted photographs and oblique photographs. Okay. So, let us look into one by one. So, let us see if I acquire the image, and that is a kind of field of view of the vertical photograph. What is the meaning here? If I draw the optical axis or the camera axis of the camera, which is completely matching with the nadir direction here like this, the nadir or the gravity direction of the aircraft, then we call it vertical photograph. Right now, it is very simple definition to understand. We will again try to modify it, try to look into this deeply in the coming lectures, where we find out there are more criteria to define a vertical photograph. But right now, understand that if the optical axis or the camera axis of a camera is matching or it is in the direction of gravity, then it is called vertical photograph, and this is the coverage of the vertical photograph from here to here. Okay, what next? Then we have tilted photograph. That means this is the gravity direction, but the axis of camera is somehow tilted. That means that camera was there, this was the gravity direction. Now this axis of camera, optical axis of camera, is tilted like this, and as a result we have this as my camera optical axis, and this coverage is called the tilted photograph. That means we are acquiring a tilted photograph. Naturally, we should expect some distortions into tilted photograph. What are the distortions? Distortions is something away from the expected one. So in vertical photograph, we have some kind of expectations that it will cover this much of area, but tilted photograph, because it is tilted, so instead of covering this much area, it will cover some kind of shifted area. We will see all these things. Further, if I further tilt the axis quite oblique way, like this, deliberately, then this is my optical axis, and this arrangement or the photograph acquired by this kind of system is called oblique photograph. You will be surprised to see here that there is a limit. If I have this gravity direction, if the axis is within 3 degrees, the optical axis, it is called tilted photograph. Vertical photograph, there is no deviation of camera axis as well as gravity direction. That is called vertical photograph. That means there could be some random error, but knowingly we do not commit any error there. But in case of tilted photograph, the deviation is there up to 3 degrees, then it is called tilted photograph. More than 3 degrees, it is called oblique photograph. That means the deviation of camera axis from the gravity direction is more than 3 degrees, it is oblique photograph. If it is up to 3 degrees, it is called tilted photograph. If it is 0 degree, it is called vertical photograph. Well, now, okay, what about the angle of coverage or field of view? In the last photograph, I have shown you 2 lines like this here, this point and this point, that is coverage of the photograph. This much length or this much area a camera is going to cover on ground surface. So now, if I have this angle called alpha 1, it is called field of view, right? And I am representing here the focal length f, and this is my image plane, or what we call negative plane, or we can call it negative image plane. So there, this is my exposure station here, you see this cross. So this is my focal length from here to here, f, and then this is called field of view of camera, and it is, this camera is going to acquire this much of length, or I can say in 2 dimensions this much of area. If I consider the 2 dimension of the camera, then let us say this is length that is being acquired by the camera. So this angle is called FOV, which is alpha 1 here, right? Now, if I increase the angle FOV, it becomes, let us say, alpha 2, which is more than alpha 1, and again it is alpha 3 here. You will see here, for the same arrangement of camera, as we increase the field of view alpha, focal length will has to be reduced, and that is also true for the consumer grade camera or terrestrial camera, right? You can see here and you can feel it here. Similarly, if I further increase my alpha, that is field of view, my focal length has further reduced. So idea is there, if I have higher coverage, I will cover more length on the ground, but at the same time you can see that focal length will reduce. And we will see in the next lecture, if focal length is less, I will have less resolution of the image. We will talk about this thing, but for time being you can just collect this information. Similarly, focal length is higher here, so I will have less area to cover compared to this area, so I will have higher resolution. You can just imagine, suppose you have a 12 megapixel camera, and if you are acquiring some information, because of that you acquire some area, and now if you divide that length or area into 20 megapixels, so each pixel will have certain value on the ground surface or on the wall or wherever you acquire on the object space, and that is called the resolution. For time being, just understand that, right? So we can see that the resolution is somehow a kind of represented by the pixel, although it is not very correct definition right now, but for right now you can assume it to be correct. We will correct it, modify it later in this lecture only. So as you see that if you have some kind of wide angle camera, you will acquire with the same 12 megapixel more coverage or more length on the ground surface or on the object surface, or each pixel of the 12 megapixels will represent higher length of the ground, or I can say less information compared to the earlier arrangement what we talked. So that's the kind of idea why we have higher focal length if coverage is less, and as a result we will get higher resolution, right? Anyhow, so we call, if the FOV is between this range, the field of view, it's called narrow angle photograph. Then we have this range for normal or standard angle photograph. Then we have more than 90 degree to 1110 degrees, we have wide angle photographs, and more than 1110 degree FOV is called super wide angle photograph. Or rather I should say, is it camera or is it photograph? No, because camera can have varying focal length, and as a result my field of view can also vary. And so we say that whatever arrangement I make at that time of acquiring the photograph, it will characterize my photograph, not the camera, because camera has a lot of facility, right? So we do not attach these values to the camera, rather we attach these values of FOV with the photograph. Okay. Now let us look into the basic terminology of the camera. First thing is that the basic optics we have here. Okay. So the first thing, let us say that there is object and which is imaged here. So there is a lens assembly here, and then it is imaged invertedly here. So the distance between this focal point, this lens where rays are converging from this point and rays are converging here. So this distance from the center of lens to this lens is called focal length. And from this point, if I go towards object, this is called distance O here, and if I go towards the image from this point, it is called I, and then I can write this famous lens equation like this. So now it is shown here that all these rays, they are basically converging on this point, let us say A, and all these rays, they are basically converging at point B here, let us say small a, small b. So that is the idea here. So we are showing only one ray here, here multiple rays we are showing. Now coming to the aperture, what is aperture? If you see in your camera like this, somewhere here, you will feel there is small hole in any camera. Now if you look at the camera carefully, then there should be a hole that allows the light to get into the camera system, and that hole is called aperture, right? If more light is going, that means the larger the aperture, more light will go into that camera and it will create bright images. If there is aperture is completely closed, no light will go. If aperture is open slightly, minimum light will go, and so it controls the image quality, the rather illumination on the image. Fine. So it is shown here that if there is aperture here of size this much, which is equal to the height of the lens here, then it is creating a focus here and it is allowing the light. So basically the function of aperture is to control the amount of light to pass in or to go into the camera. Now let us look into this thing. As we know that we can vary the focal length, similarly we can vary the size of the aperture. So what is the effect here? As you know that there is a focal length like this, and as a result this is the object here on the right hand side, and there image has created of this object, inverted image, as you know. Now let us think that you have increased the focal length from here to here, by bringing your lens backward towards the, or bringing your lens towards the object. That means, if you remember, if you open your lens telescopic tube, it will more in the length, and as a result you are increasing the focal length, and because of that what will happen? This object image will be increased, the size of the image will be increased here. But you can see here, because of the length increase of, or the increasing in the focal length, the amount of light that was coming earlier is still same, because aperture is same, the opening is same, and as a result you will get dull image or little less illuminated image compared to this image, right? On the other hand, what if I want to have the same illumination, but at the same time I want to increase the focal length? That means I want to have higher details, clear image, better image. So what can I do here? I need to increase both focal length as well as aperture size. Okay, that we are showing here, and now we are getting larger image or image with higher details, as well as we are getting same illumination what you get here in this case. So now we understood that there is some relationship between the focal length and aperture size, and now we can say, because focal length is controlling my details and aperture is controlling the light amount or amount of light or the illumination or the quality of visibility or radiometric quality, and focal length is controlling my spatial quality, the details, right? So let us have the relationship between the two. So aperture diameter and focal length ratio is called relative aperture. Now we can say that the ratio of focal length to relative aperture, and it is also called the f number, or sometimes aperture stop, and it decides the brightness of the image. Secondly, now it is the moment we take the ratio, it is independent of the focal length now, right? It is indicated by f by n, where n is the f number. Okay, what is the meaning here? So let us say I have aperture area A, and if I reduce it by 2, that means I am reducing my light, the amount of light, by 2, or I can reduce it by 4 times, 8 times, and so on. What will happen? I need to reduce the diameter of the aperture by under root of this, let us say under root of 1, under root of 2, under root of 4, and so on. So accordingly, as we told in the last slide, aperture diameter to the focal length ratio. So my diameter is reduced by root 2, root 4, root 8, and so on. So you will find out these are the f numbers, f 1.4, f 2, f 2.8, and so on. So they are representing the diameter of the aperture, not the area. If you make it a square of this, 1.4 square, it is 2, right? So or 2 square, it is 4. So it is indicating that we are reducing the area by a factor of 2, right? And as a result, we are reducing the diameter of aperture by a factor of under root of that factor. So let us see here, this is my lens. So rays are going like this, focusing here, right? So aperture size is highest. Now aperture size I am reducing, so here, and then here again I am reducing the aperture size. So basically this arrangement is going on like this, and generally we have in this ratio only f 1.4, f2, f 2.8, and f. They are fixed discrete values available with the cameras. So here I am showing all this together. Okay, so what is a shutter? Shutter is a kind of, it controls the timing of opening. So aperture is opening, and if I control the shutter, that means I allow the light for certain duration, and that is called the operation of shutter. So shutter is kind of shutter of your shop. So you open the shutter, light will come, and if you close the shutter, light will not come. Or rather, if you open it, shut it, it will come for that duration. So that is the shutter, the operation of shutter is. Now shutter speed, if you imagine that sometimes you get blurred images, we try to, you have a pet dog with you in home, and you try to, he is making some kind of entertainment or some kind of, natural movements, or you want to capture it. If it runs very fast, and if you use a camera, you come across some blurred images. Why? Because if the shutter is opened for large time, during that time that movement has happened and that movement has captured, and as a result you get blurred image. What is the solution here? Open the shutter for very less time. So during that time, even that movement happens, it is so less movement that it will appear as a static object, right? So that is the operation of the shutter. So you can see here different shutter speeds. So if we have high time for exposure compared to this time, I have very clear image because the shutter speed very less, 1/500 second. That much of speed, that much of time if we open the shutter and close it, and as a result I get very crisp image. Now focal length, you know focal length many times. It is basically if there is a lens assembly and it is called front nodal point N1 and there is a real nodal point N2. So the distance between the real nodal point and the image or the image plane, it is called the focal length, right. So now in the digital camera we have equivalent focal length concept that we will look into this now. Okay, focal length versus sensor size, important concept. Let us say this is my camera and this is the lens here. So this is the focal length because image is placed here or the lens sensor is placed here. Let us see, this is my sensor or what we call film sensor or call it the film or oblique sensor. Now rays are coming from infinity, so they are parallel. They will be imaged like that with the help of lens. Okay. So this is my called full frame sensor which has complete size like this. Now today if you see our mobile cameras have a sensor. So what do we do here? We reduce the size of the sensor and that is called the cropped sensor. Okay. Let us look into that. Let us make the camera small, okay, and this is my lens, fine. I have reduced the size of lens also because I want to bring my miniature camera, small cameras. So now light is entering like that, it is being focused at some point like this. So the size of the sensor has also reduced now, you see, compared to the earlier sensor. So this is called the cropped sensor, and as a result of that now you can see we have small cameras, and cameras are so small that we are fitting into our mobile phones, and that is the reason they are all cropped sensors, and it is because of the technology only. So this is my cropped sensor compared to the full frame sensor, right. So all these mobile cameras are using cropped sensor, not the full frame sensor, and full frame sensor is called 35 mm full frame sensor, and the definition of full frame is 35 mm or sometimes 36 mm into 24 mm or 26 mm, just check, yeah, 24 mm. Now ISO number. ISO number is controlling the quality or the radiometric quality or the brightness of the images. You see, if I put into dark time this ISO 250 and I am increasing the ISO now and I am getting brighter images, right. So that is the kind of operation of the camera. So camera when provides higher ISO number, even in the time of dark, it can acquire good images, right. So it is basically the sensitivity of the camera to the brightness of the scene. Now resolving power. Okay, what is the resolving power? In general we can say if there are two objects like this, you know, side by side, let us say one is my hand, one is my mobile camera, and if I take the photograph, in the photograph if these two objects are looking separately, that means they are appearing distinct objects or two objects, I will say that the camera is able to resolve the distance between the object and this object. So this is the distance here, right. So let us say this is the distance shown by my finger between the two. So this is the distance here. So that is, this distance is resolved by the camera. Now we have three terms here, the well resolved, that means I can see two objects as a distinct objects. Just resolved, that means they are appearing very close to each other but still they are distinct. And finally not resolved, they are appearing as. Now we have just talked about the resolving power of lens or the resolution of camera. Okay. So, let us look into the relationship between the resolution, field of view and focal length, because we have been arbitrating again and again that if I increase the focal length, my resolution will improve, and as I told that field of view is decreasing. Well, look into this thing now. That is a very clear term that if I increase the focal length, my resolution improves, no doubt. And you can understand it by simple logic. If I increase the focal length, the field of view will be less, and as a result now this length which is on the ground surface is less acquired by the camera. Now I have 12 megapixel camera, so 12 megapixels are acquiring this much of space. Let us see this tablet for example. Okay, now I increase the focal length, I can see that the space on this tablet may be from this to this completely, or the less space on this tablet will be acquired. Again, my megapixels are 12 megapixels, so number of pixels are fixed, and as a result each pixel is acquiring less space, and I can see that if there are small objects, they will be clearly demarcated, or they will be, I can distinguish them very easily if pixel size on the ground is small, which means if I have high resolution, that means my pixel size is small, that means I have higher focal length compared to the lower focal length, I have higher resolution. Similarly, it has a direct relationship with the FOV, because higher the focal length, higher the resolution, higher the focal length, less the field of view. So, automatically field of view is inversely proportional to the resolution or focal length here, right. So, that is the relationship here. So, I can say this photo with the same camera arrangement, it is focal length is high f1, let us say it is f2 and it is f3. So, I have f1 more than f2 more than f3, right. So, I can see here this is my field of view, which is, I can say the coverage, okay, let us call C1 is less than C2 is less than C3, and this is my C2, this is my C1, and this coverage is my, let us say, C3. So, higher the coverage, less the resolution, simple. Ultimately, we talked about the cropped sensor. Now, we have something called crop factor. What is the crop factor? If I take the standard film camera of 35 mm film, and if I calculate the area, that will be equal to, let us say they calculate like that, mm square. Now, if I take the ratio of this divided by the my cropped sensor area, which is let us say this mobile phone, this is, so if it has this mm square area, then if I divide it by this mm square, I will get this crop factor of 55. Try it yourself for other cameras, you can get this data from net, right. So, this is called the crop factor. So, I know that the area of full frame divided by the area of crop sensor, it is called crop factor. This is the definition of crop factor here, which is also written here. Then what is the FOV of the crop sensor? It is FOV of the full frame divided by crop factor, direct relationship. What about the focal length of crop sensor? Focal length of the full frame divided by under root of crop factor. So, you will get the focal length also of the crop sensor. That means, you find out what is the focal length of this Apple iPhone 5, it should be around 4 mm. Try it yourself. Why? Use the crop factor logic. Okay. Now, we have learned all the things about camera, platforms and other terminology. Okay. Being a photogrammetrist, what photogrammetrists say ultimately about the camera? They say three things. Camera is non-metric camera, camera is semi-metric camera, or camera is metric camera. Non-metric means the interior orientation parameters are not known. In general, all the consumer grade cameras are non-metric camera. I am telling you one thing, that focal length itself is an interior parameter of a camera. We will look into this, what are the interior parameters or interior orientation parameters of a camera. So, there are three interior orientation parameter, focal length is one of them. So, if focal length is not known or the 3 interior parameters are not known, then it is called non-metric camera from the photogrammetry perspective. If out of 3 parameters, let us say focal length is known, we will call it semi-metric camera, or even the other 2 parameters are known and focal length is not known, we will say semi-metric camera. And if all the 3 parameters of interior orientation are known, we will call it the metric camera. So, that is the definition from the photogrammetric perspective. Well, now you might be thinking, let us say you have some high-end camera of Canon or maybe Nikon or whatever, which is a DSLR camera, and it has some range of focal length 18 mm to 55 mm. You have lens, and we can fix some 18 mm, then some other lens and so on. Then the length or the focal length is known to you. You think like that. In fact, when we go for the photogrammetry, this length is not perfectly known in a sense. It could be 18 mm, it could be 19 mm, it could be 18.5 mm. For the photogrammetry, for the 3D measurement, focal length plays a very vital role, and we should know its exact value. And that is why we go for the calibration process, where we determine the exact calibrated focal length, right? And the location of the principal point. We will look into this, what are these, but these are my 3 parameters of interior orientation of camera. So, a metric camera always know these 3 parameters, right. So, in the next lecture we will start with the vertical photogrammetry, and there whatever we discussed today in this lecture, they are the preliminary knowledge about the photogrammetry field, but they are important information without which we cannot proceed further, and that is why this lecture is designed like that only. So, let us meet in the next lecture on vertical photogrammetry. Thank you.